Good day, everyone. So we will have another module for today, module 11, which is the harmonic motion. So before we discuss kung ano ba yung mga concepts, formulas, and problems na nakapasok sa harmonic motion, we will have first the lesson objectives dito sa ating module first. Makaka-encounter tayo dito ng mga spring later, no? So we'll be able to compute the spring constant of a simple harmonic motion of a spring. So most of the time, dito yung mga problem na na-encounter natin sa harmonic motions are problems connected sa springs. So may nabanggit ako kaninang simple harmonic motion wherein matatouch din natin sa introduction part ng ating module. Next is for us to be able to calculate the maximum velocity, period of vibration, and amplitude of simple harmonic motion, particularly ng spring. So mayroong mga maximum volume, mayroong period of vibration na ma-encounter later. Of course, if may maximum, meron ding formula na gagamitin para makuha yung maximum velocity na yun. Actually, meron ding maximum acceleration tayong madadaanan dito sa harmonic motion. So let's proceed in discussing kung ano nga ba yung concept ng harmonic motion. So here in harmonic motion, of course, we have the simple harmonic motion. So as you can see here, meron tayong spring wherein meron tayong weight, itong part na to, yan yung weight natin. But kapag nilagay natin yung weight natin sa spring, ito lang siya, nasa equilibrium position siya wherein naka firme lang siya, no? Stationary lang siya, meaning hindi siya bumababa, hindi na rin siya tumataas. Equilibrium na lang siya. But if you push this mass, tong object na to pataas, makukompress siya kagaya ng nasa first illustration natin ito. Okay? So yung displacement natin is pataas. Kaya yung S na to, and then kung napapansin nyo, merong F. Yung F na yun ay yung tinatawag nating restoring force. So sa spring, alam naman natin, familiar tayong lahat sa spring. Once na tinulak natin or kinompress natin yung spring, di ba lumalaban yung spring? O pag binitawan natin yung spring, is palabas siya, kumbaga, bigla siyang, pag kinompress natin, pag binitawan natin, and release natin, parang niya tinutulak yung sarili niya palabas. Tapos babalik siya sa kanyang equilibrium position. Kagaya nito. So, pag hinatak naman natin, pag pinul natin pababa yung ating weight na ito, yung spring natin is ma-stretch and magkakaroon tayo ng displacement naman na pababa. Tapos, pag nirelease natin yung pagkakahila natin dito sa spring, magkakaroon tayo ng restoring force na pataas. So, ito yun. Itong F na to, pataas siya. Displacement natin is pababa. So, kumbaga, parang titingnan natin, lagi si restoring force and si displacement natin is opposite direction. So the type of vibratory motion in which the acceleration is proportional to the displacement and always directed toward the equilibrium position is called the simple harmonic motion. So yung acceleration daw natin is laging towards the equilibrium position. So as you can see, ang ating acceleration dito is ito, di ba, yung A. Tapos yung direction niya is pataas, pabalik dun sa ating equilibrium position. Tapos kapag naman kinompress natin yung spring, ang ating acceleration din is pababa, which is pabalik sa ating equilibrium position. Okay? Yung direction ng ating acceleration is lagi talagang opposite sa displacement din. Okay. Di ba pag hinatak natin yung spring, tapos nirelease natin, mag-accelerate yung spring natin pabalik, pataas. Kabaliktaran niya yung displacement. Tapos, parehas siya sa direction ni restoring force. When the object is released, the restoring force produces an acceleration. Gaya na sabi natin kanina. That is proportional to F and inversely proportional to the displacement and opposite in direction. So we have here formula sa upper right ng screen natin. We have F is equal to Ks or negative Ks. So negative Ks indicates that the force or restoring force is opposite in direction sa ating displacement S. So yung K natin as the spring constant, most of the time is given yan unless yan yung pinapahanap sa atin sa problem. So dito, etong F na to, para ma-compute natin yung restoring force ng ating spring, multiply lang natin si spring constant sa na-displaced ng ating spring. So we also have A is equal to negative Ks over M, wherein yung M, kung naalala nyo yung concept sa second law of motion, yung F is equal to ma. So doon lang naman siya galing. Kumbaga, pag pinalitan mo yung F ng ma, di-divide mo both sides yung equation, mapupunta sa baba sa kabilang side yung mass natin. Okay, so yun yung harmonic motion natin. So type siya ng vibratory motion wherein yung acceleration is proportional to the displacement but opposite in direction. So we also have here the concept of amplitude, period, and frequency. Pag sinabi nating amplitude or A na malaki, ito ay displacement lang but in maximum manner. Kumbaga, pag may displacement ka, pag nasagad yung ating displacement, yun na yung ating amplitude. So ito ay depende kumbaga papunta o either side of the equilibrium position. So ibabalik ko lang yung sa illustration natin. So ayan ano. So ito ang equilibrium position natin. So kapag nag-displace tayo, kinumpress natin yung spring, magkakaroon tayo ng displacement S. And once ma-reach niya yung maximum displacement upon compression, ma-reach natin yung amplitude niya. And on the other hand, yun naman sa kabila, pag in-stretch natin, ano, magkaka-displacement siya. And once ma-reach natin ang ating dulo, kumbaga hindi na siya ma-stretch, yun na yung ating maximum displacement S or yung tinatawag nga nating amplitude. Next, we have the period T of the vibration is the time between two successive passages going in the same direction through a point in the path of the body in simple harmonic motion. So period, it is just that time. So meaning ang unit natin dyan is seconds or hours, minutes, depende sa problem, sa given. And lastly, we have the frequency. It is the total number of vibration completed per unit time. So formula natin sa frequency is the reciprocal of period. Ang unit naman niya is hertz or vibration per seconds. So for the formula of T, pwede natin gamitin yung reciprocal ng frequency. And then seconds ang kanyang unit. So for the formulas na ginagamit dito sa problems when it comes to simple harmonic motion or harmonic motion, is itong mga nakapresent. So as you can see, we have first, A sub C is equal to 4 pi squared A over T squared. Wherein yung ating acceleration C na yan, o A sub C, is the maximum acceleration na ma-experience sa problems when it comes to simple harmonic motion. Ang ginagamit natin dyan is A, di ba? Yung A natin is the amplitude or the maximum displacement in a spring, o depende kung ano yung binigay ni problem. But on the other hand, meron tayong A lang. Ano? So ito ay hindi maximum acceleration. S yung gagamitin natin. So kung mapapansin nyo, ang difference lang ng dalawang formula natin is yung A and then yung S. So pwede nyo makabisado yung isa dyan, tapos papalitan nyo na lang yung mga values. So tandaan nyo lang, kapag maximum acceleration, ang na-experience na is maximum displacement or yung ating amplitude. Pag hindi naman maximum displacement, S lang siya, tapos hindi siya maximum acceleration. Aside from that, we have T or the period. Ang formula natin dyan is 2 pi multiplied by square root of S or the displacement over our acceleration. Wherein pwede rin natin tandaan na yung period is ganun din, 2 pi, pero ang nasa loob ng square root natin is yung mass over the spring constant. So actually, na-derive lang naman yan galing dun sa formula na pinaset kanina sa upper right of the screen. So ibabalik ko lang. Yung A, etong A, papalitan lang natin nitong value na to. Yung A is equal to negative, pero alisin nyo na yung negative. A is equal to Ks over M. Pag pinalitan nyo yun, may makakancel lang, and then magre-result sa square root of M over K. Okay. So pwede nyo kabisaduhin, okay lang naman. Wala namang problema. Basta alam nyo lang saan siya galing, just in case na makalimutan. For the velocity, may V sub C. Ito ay maximum velocity sa ating problem. So as you can see, 2 pi over T, then minultiply sa amplitude. So parang ganun din yung concept sa acceleration. Sa maximum acceleration, A yung ginamit. Pero kapag hindi maximum velocity ang pinapahanap, you may use this formula. 2 pi over T multiplied by the square root of the difference between the square of amplitude and displacement. So madali lang naman kabisaduhin yung formulas natin. So, lastly, we have 2. S is equal to the amplitude multiplied by sine 2 pi. Then yung F na to is the frequency na pinresent natin kanina. And then T. And lastly, acceleration is equal to negative 4 pi squared frequency squared times S na displacement. So we have here a first example here in harmonic motion. We have here example number 1. Binigyan tayo dito ng mass. A 50-gram body is attached to a string with a spring constant na 1,500 dynes per cm. It is displaced 12 cm from the equilibrium position and released. Determine the period of vibration, the maximum acceleration, and the acceleration of the body when it is 4 centimeters from the equilibrium position. Okay, so yung binigyan din tayo ng 12 cm, which is yung ating, consider na lang natin siya, ay yung ating amplitude o yung maximum displacement na na-experience ng ating body na 50 kilogram. Okay? Pinapahanap sa atin is yung T o yung period natin. Pinapahanap din yung maximum acceleration o yung A sub C. And then acceleration lang at displacement per centimeter. Okay. So, meron tayong mga formulas kanina. So, T is equal to 2 pi square root of M over K. So, may pinasan tayong ganyang formula. So, check natin if yung mga values ba tayo. So, yung 2 pi, meron, okay, constant yan. And then yung M natin, binigyan tayo ng mass, which is yung 50 grams. And then, pwede natin i-convert yan sa kilogram. 0.05 kilogram. Tapos, meron tayo ng K. Kaya lang, as you can see, yung dynes is hindi katugma ng kilogram. So, kung pwede natin gawin dyan is i-convert natin yung ating dynes. So, yung dynes natin na 1.5 over cm, multiply lang natin yan sa 1 Newton per meter is equal to 1,000 dynes per centimeter. So, yung value niyan is 1.5 Newton per meter. So, plug in na lang natin yung values. So, mag-ingat lang kayo sa sign kasi baka bigla nyo i-substitute yung 1.5. Tapos yung dun sa may formula natin, mamamali kayo. So, yung ating 0.05 kilogram over yung K natin na 1.5. So, ang value natin dyan is 1.147 seconds. So, ito yung ating period. Ano? So next we have the maximum acceleration. A sub C is equal to, anong formula natin dyan? So we have here a formula na 4 pi squared. Yung displacement natin, yung maximum displacement, which is yung ating amplitude over A square. Ayan. Substitute lang din natin. So mahalaga na kabisado niyo yung mga formulas natin. So 4 pi squared, constant yan. For the amplitude, we have a 12 centimeter over yung time natin is 1.147. So I hope in-store natin itong value na to. Sabihin natin store sa A. So ngayon, pwede na natin siyang simplify. So squared itong T. So huwag nyo kakalimutan yung squared. So magiging value natin dyan is 360 meters per second squared. Ay, centimeter yan. Dahil 12 centimeter siya. Then yung 1.147 natin na nakastore sa A is second. And lastly, for our acceleration at displacement for centimeters, we have, yun na lang ulit gamitin natin formula, but this time, papalitan natin yung A ng S or yung displacement. So T squared is equal to 4 pi squared times 0. Kahit huwag na natin i-convert yung 4 centimeters, okay lang naman. Over yung time ulit natin na nakastore sa A. Yan ay 120 centimeter per second squared. Okay. So for example number 2, a body vibrates in a simple harmonic motion with a period 6 seconds. So ilagay lang natin yung 6 seconds. And an amplitude of 8 centimeters. Pinapahanap sa atin yung maximum velocity. And then yung velocity natin at 4 centimeters displacement or away from the equilibrium position. So may mga inintroduce sa atin na formulas kanina. We have the VC is equal to 2 pi A over T. Ayan. Is equal to, so plug in lang natin yung values. We have 2 pi times yung 8 na 8. And then yung time natin na 6. So we have here 8.377 or 378 centimeter per seconds. And for our velocity at 4 centimeters away from the equilibrium position, sorry, is equal to 2 pi over time. Tapos, multiply by square root of a squared minus s squared, wherein yung a is yung amplitude, and then yung s yung given na displacement. So, we have 2 pi over time natin na 6 times square root ng a natin is 8 squared. 8 squared minus yung s squared natin na 4 centimeters. Okay. So, ang value natin is magiging 7.255 centimeter per second. So, ito ang ating velocity. So, mostly is direct substitution lang naman dito and basta alam natin saan ba ginagamit yung ating mga formulas. We have here example number 3. 5 Newton ball is fastened to the end of a spring as shown in the figure. So, dito ay naka-fasten siya or naka-secure siya na hindi magagalaw. So, ito yun. Ito yung ball natin na 5 Newton. A force of 2 Newton is sufficient to pull the ball 6 centimeters to one side. Determine the force constant and the period of vibration. So kanina meron tayong pinresent na formula, which is yung F is equal to Ks. So ang pinapahanap sa atin is constant or force constant, which is also the spring constant. So parehas lang sila ng spring constant. Okay, so kung ganun pala, divide natin both sides ng S. So magkakaroon ka ng K is equal to Fs. 2, 2 lang yung ating, 2 yung ating force, and then we have a 6 centimeter na value. Pero, convert natin yung 6 centimeters into meter, we have 0.06. So pag sinabstitute natin yan, we will have 33.33 Newton per meter. Next, we have the vibration or period of vibration na T is equal to 2 pi square root of m over k. Yan. So, yung ating period of vibration, wala sa 2 pi square root of yung mass natin is wala namang mass na binigay, but binigyan naman tayo ng weight ng ating ball. So, paano natin mapapalabas yung mass niya? We'll simply divide yung 5 sa ating 9.81. And then divide natin siya sa ating spring constant. Okay. Spring constant na K. So, pwede naman natin actually na ito ay store natin sa A. Para masakto yung ating sagot. Yan. So, 2 pi square root of 5 over 9.81 divided by yung sa A natin na spring constant. So, we will have a period of vibration of 0.777 seconds. For last example in this module, we have here the position of a particle in a given by the expression x is equal to 4 cosine 3 pi t plus pi. Okay, where x is in meter, yung x natin is naka-meters, yung t natin is naka-second. Okay. Calculate the frequency, the period of motion, so t yun, and then the amplitude of our motion. Yeah. So ito kasing given natin na x is a function. So ito ay ginagamit. Yung form na ito is ginagamit sa mga problems like spring. Ayan. So ang actual formula niya is x is equal to a cosine yung ating angular frequency t plus pi. So kung i-adapt natin yung formula na ito and i-connect natin sa given function x natin, we could say na yung a natin o yung amplitude na ito is equal sa 4. Wherein naka-meter siya dahil a is a displacement and ala namang ibang unit na binanggit when it comes to length or displacement except for the meters. So therefore, ang ating amplitude is 4 meters. So nauna natin isolve yung ating amplitude. So based lang naman sa formula. For the frequency, ayan. So kung mapapansin natin, we have here, ayan, yung angular frequency natin na small omega. small case omega, or lowercase omega, which is equal to 2 pi f. And as you can see, if i-connect natin yung given natin na to sa taas, sa ating formula, we could say na yung omega o yung angular frequency is equal sa 3 pi. Okay? So, ito ay 3 pi. Ayan, 3 pi is equal to 2 pi over f. Cancel yung pi. Both sides. Therefore, f is equal to 3 halves or equal siya sa 1.5 hertz. Ayan. So, meron tayong frequency. And lastly, for the period, meron tayong formula na t is equal to 1 over f. Since meron na tayong f or yung frequency nga natin na 1.5, divide lang natin yung 1.5 sa 1. You will have 0.67 seconds. So meron na tayong period na hinahanap, which is 0.67. And then we have frequency as well, na 1.5 hertz. And lastly, we have the amplitude 4 meters. So that would be all for our module in harmonic motion. If you have questions and clarification with regards to our discussion in this module, feel free to drop your concern in our group chat so that masagot natin ng mas maaga. So thank you for watching our lecture video, and that's all. Thank you.